Okay, guys, let's have some fun with this. So some of you might say, "Well, we're talking about X." Oh man, let me get out of here. Hold on. We're gonna make it easy, guys. Okay. So we're gonna try to simplify what it is, understand. So the question is, this symbol means less than, right? So what they are saying, so they are saying, let me explain to you. They are saying x to the power of minus 2 is less than x to the power of minus 1 for whatever value of x. So is it true or false? How you can prove that? First of all, let's try to why this is different. What do they mean when they say x to the power of minus 2? It's the same thing to write. So this is the equivalent of 1. I got 1 over x to the power of 2. Okay? So that's another way to write this one. Is less than 1 over x. That's the same thing, and I write it differently. So, things starting to get easier, right? So, is it true? How to prove that? We can try to do that. Just let's get some numbers. Let me get to. Let me put example. Okay, example. Let's say if x equal to 2. Okay, what I'm going to have? I'm going to have 1, 2 to the power of 2, right? Is it less than 1 over 2? So I'm going to have 1/4, 1 over 4, which is 1.05, right? Is it less than 1 over 2? This is 1.50. So it's right for 2. Okay, but understand, for any value of x, so I'm just trying to take some value. So I'm experimenting right now, okay? So I'm trying to understand. But this is not a real demonstration. So let me take example. Let's say, so we see when we got x equal to, it's true. But understand, x can be any value. So let's take an example. What about if I take x equal minus 2? What I'm gonna have here? I'm gonna have minus 2, right? Okay, I'm gonna have minus 2 to the power of, so it's still gonna be it's still gonna be a 0.5, but here I'm gonna have 1 over minus 2. I'm gonna have minus 0.5. So this is not true. You see what I mean? I just change it when I have minus 2. So that's dead wrong. That's dead wrong because this is a negative value. Okay, so as I can see, I can give an answer to say not for any value. Okay, but the best way to do it, so this is good. I just can say no. That's when I have minus 2, so I cannot say that for any value of x. That's it. I'm right. But if you want to be a mathematician, so if we want to have a general idea, we can try to have a general idea of it. Let's try to have a general idea of it. Okay, guys, we're gonna try to make it. But by the way, we just prove it. But we can try to make it, and that means I'm gonna have a border. It's gonna be a demonstration. Okay, so let's understand. They say x to the power of minus 2 is less than x to the power of minus 1, which means the same thing. I can write it this way too. I can say that's the same thing. I can say, x to the power of minus 1 is more, that means it's greater, is greater than to the power of x minus 2. You understand what I mean? It's the same thing. If I say 1 is less than 3, that the same thing to write 3 is more than 1. Okay, so I just write it in a different way, but that basically the same thing. Okay, so now what I'm gonna do, so from here I can say 1 over x, right, is greater than 1 over x to the power of 2. So which means that's, remember I said that's another way to write this one, and that's another way to write this one. Okay, now starting, since this is greater than, if I say, so generally if I have, let me show an example. If I say 5 is greater than 3, if I have to minus uh, 3 minus 5 minus 3, that's gonna give me, 2. So it's always gonna be a positive value, okay? Because this is greater if I try to subtract. So I can always say 5 minus 3 is gonna be greater to 0. That means it's gonna be a positive value. Okay, this is true for anything. There is a general theorem that say if A is greater than B, and then I can always write A minus B is greater than 0. You can try to put number for every time you got whatever the number. If I have 9 greater than whatever, than 4, so I'm sure if I have 9 minus 4, it's still gonna greater than 0, because what I'm gonna end up it's 5. Okay, so that's the idea when they're talking about you know hold on. That's what I did here. Since x to the power minus 1 is greater than x to the power minus 2, so I just write it differently. So from there I can say, or I can say 1 over x, right, minus 1 over x to the power of 2 is greater than 0. Okay, I already explained this, is greater than 0. From there I can simplify these expressions. Okay, can simplify this. How to do that, the way to do it, so it's the same thing when you are trying to find a common denominator from those two, x and x squared. So the common denominator is gonna be, I can say this is equal to, so let me explain it to you for fractions. If I have a over b minus c over d, I can always write it down a time, that means a times d minus b times c over b times d. Okay, that's a way to simplify it. From there I can say x times 1. See, I can say 1 times x squared. Okay, so, okay, so it's gonna be 1 time 1 is gonna be 1 time x squared, right? This is the multiplication I did, and this is gonna minus 1 time, if you want, 1 time x, and then over what? Over what? So it's gonna be over x time x2. That's gonna give me x time x squared. So to simplify, I end up with x to the power of 2, x to the power of 2 minus x. Well, this is, by the way, this is still, I'm trying to find if it's always greater than 0, over x cubed. Is it greater than 0? So I can try to simplify by x. Simplifications, the simplification will give me what? Simplify by x factor. So I'm gonna have, that's a simplification, I'm gonna have x here, I'm gonna have minus 1 here, and I'm gonna have x squared here. Is it, if this expression always be greater than 0? So understand what I did here. I just put x in factor which means this is x factor x minus 1. You see what I mean? Over this is x times x squared. That's why I simplified that by x. I end up with this one. So now here's what I have. So I have x minus 1 over x squared. So the question is this gonna always be positive? Okay, take a look at this. Let me write this. Let me go to another page so that I can write this. Okay, x minus 1 over x squared greater than 0. Let's see. So we end up x minus 1 over x to the power of 2 greater than 0. Is this true? What can I say? Is this, in fact, is this gonna be always positive? What I know this part gonna always be positive, right? It's gonna always be a positive value. So I need this part to always be positive. When this is positive, I'm fine. When it's gonna be positive, as long as it's not greater than 0. So by the way, this is not, as long as this is greater than 1, okay, it's still gonna be a positive value. So why? Because if it's less than 1, let's say if I have like, I don't know, if I have like a minus 2, it's gonna be minus 3. So the result gonna be negative. You understand what I mean? So I know this is always gonna be positive, but what happened for this part? This part is depend when I have x, greater than 1. So I'm sure this part gonna always be positive. So the only way for these expressions to always be greater than 0, okay, this is greater than 0 if only x is greater than 1. Every time x is greater than 1, I will always have this is positive. So to answer my questions, to answer this question, this is true only when x is greater than 1. So to come back to, let's go back to our specific question. This is true only, so x to the power of minus 2, it's less than x to the power of minus 1 only when x is greater than 1. And we can try to put some value when they are different than 1. We're gonna see this not gonna be true. So this gonna be only, see, only, we can say that only if x is greater than 1. We can try, if you try to put some value, we did it before. Example, when we put x equal 2, x equal 3, x equal 1 point whatever, so it's only when x is greater than 1. Okay, so I hope that you understand this, guys. Okay, so which means when we do it like that, it's like we do a generalization. So remember our first step, we just try to experiment. We just put value. That's experimentation and trying to understand what they're talking about. But sometimes in mathematics, to prove something, we try to generalize. That's why we did put in x. And when we end up with these expressions, we know for sure that x squared is positive, always positive. But we know this to be positive if only x is greater than 1. That's why now we end up with in generalization instead of taking value 1, 2, minus 5. So now we know generally whenever x is greater than 1, so the expressions, that's mean what they say here at the beginning, is gonna be true. Okay, take care, guys, and see you for my next video.